Now in Salina, and we're about ready to go on board the NASA DC-8 aircraft, which you can see behind me. And what we're going to be doing with this aircraft tonight, we'll be flying throughout much of Kansas. And what we're going to be doing is using a specialized instrument on this aircraft called a LASE instrument, which is a LiDAR, or a laser radar. And what we do with that instrument is we look both above and below the aircraft at the same time, and we fire this laser. And we use the laser to measure profiles of water vapor, or the amount of moisture that's in the air. We can use to understand how and where thunderstorms form at night, which is really the main objective of the Pecan mission that we're in here, is to understand where these thunderstorms form, what are the mechanisms, how long they'll last, and how far they will travel. Well, these thunderstorms that form in the Midwest are somewhat unusual because here in the Midwest, actually the majority of thunderstorms form at night, and they can produce a large amount of rain, flooding rains, which we've seen, for example, over the last several weeks in Missouri. And so we're trying to get these data sets to look at how these storms form and how much rain this can produce, which are, help us get better warnings on floods, for example.
The mission requires the airplane to be maneuvered as close to the storms as the scientists require to get the measurements that they seek. So the pilot is really the last safety device between the scientist, who may not understand the fragilities of an airplane, and the accomplishment of the mission.
Kansas itself is sort of the center, if you will, of this activity where these thunderstorms occur. It's also obviously very flat and had relatively few trees, and that's important. They have a much better field of view for looking at these thunderstorms during the night. And so because of that, as well as the actual location, it's very easy for us to conduct this versus someplace that's very hilly, for example.